In this video, we're going to talk about nonlinear functions. As you may recall, linear functions have a constant rate of change, and the graphs of linear functions are always straight lines. What we're talking about now are nonlinear functions, and you can see that I've bolded and underlined a couple of things in my definition here, and I will read to you. I am aware you can read to yourself, but just as a matter of emphasis, I want to make sure you don't confuse these two concepts of linear and nonlinear. Linear functions are functions that do not have a constant rate of change. The graph of a nonlinear function is not a straight line. Okay, so can we recognize nonlinear and linear functions from tables? Let's see. On my left here, in my first table, the rate of change on the inputs between them is 1. 1 to 2, 2 to 3, 3 to 4, 4 to 5. That's pretty clear that the rate of change here in between these is 1. On the output, what do we have? 8 to negative 16, so that would be minus 8 to negative 24 minus 8, negative 32, negative 40. This represents, according to my handy-dandy table, a linear function because I do have a constant rate of change. As you can see, I am going up by 1 on the left and down by negative 8 in between each set of values. All right, I'm going to slide this up so we can take a look at our second table. And once again, do we have, I'm going to make this a little larger, a constant rate of change? Well, on my inputs, apparently I do, between 1 and 2, 2 and 3, 3 and 4, 4 and 5. How about on my outputs? 1.5 to 2.5. Okay, that's 1. 2.5 to 5.5. That is not the same as this first one. In other words, the distance between this value and this value is different from the distance between this value and this value. So I can say, sorry about that the rate of change is not constant. And in saying so, pardon me, since the rate of change is not constant, this function is a nonlinear function. It's still a function because none of those input values repeat, but it's a nonlinear one because the rate of change is not consistent between the values, 1, 3, 3, 2. That doesn't work. Here you can see that it is 1 between each value. If it had been 3 between each value here, that would have been a linear function. And finally, I've got one more example, and I'm sorry, I'm going to make a little noise. Move these things out of the way. In our last one, let's take a look. Once again, on the input values, we have a constant rate of change between 1 and 2, 2 and 3, 3 and 4, 4 and 5. And on our outputs, no, we do not have a constant rate of change. The distance between these two values is 2, between this value and this value is 3, between this value and this value is 4, and between this value and this value is 5. This would represent a nonlinear function because the rate of change is not constant. Okay, in other words, it's slope. So you're going to get a curve or something when you graph it. And there you go. There's my evidence of this.